Hey everybody, it's Bruce and the dog on the floor, and today we're going to be talking about a Julia framework called Flux again. And since the programs written in Flux can sometimes be difficult to understand, we're going to use a notebook called Pluto to actually help us manage that process. So it's going to be a lot of fun. Let's get started. If you're like me, when you're learning a framework, one of the things that you do is go straight to the example code. Well, I do the same. And in Flux, the examples are in a place called the model zoo. Now, don't feed the animals. So one of the models that I've been trying to experiment with is a FizzBuzz model. And if you haven't played it before, FizzBuzz is a game that essentially is a childhood counting game. And each player, one after another, says a number, 1, 2, 3, 4, 5. But if the number is divisible by 3, you say fizz. If the number is divisible by 5, you say buzz. And if it's divisible by both, you say FizzBuzz. And the reason that I like this, it's the same reason that I like to explore Elixir's OTP concepts with a basic counter. I don't have to think about the complexity of the problem. It's a basic problem. I understand it. The rules are clear. So when I first jumped in here, it was relatively sophisticated. I didn't know what all of the jargon meant. And one of the things that I looked for is a way to explore all of these abstractions in a new way, was to load the whole program into a concept called a notebook. And if you've been following Julia, or if you've worked with machine learning or data science for a while, you know that a notebook is just a tabular form where you can intersperse your own comments and research into it. Well, the thing that I like about the Pluto Notebook is that you can have one running cell at a time, and updating one cell updates all the other cells that are based on it. So it allows me to quickly play with concepts and mark the concepts as I go. So that's what we're going to do. We're going to take this project and we're going to drop it into the Pluto project. One of the things that I liked about Julia was that even though it was a new language, you could easily call services in languages beneath it, like Python. And one of the Python programs that was super interesting to me was a program called the Jupyter Notebook. And it allowed me to essentially track individual elements of the language in cells as if they were on like a big, long markdown document with live code interspersed between. And it made it great for working with problems like data science and machine learning problems, because you could essentially do your research using the math of computer science, and then you could describe your work as you went. But the one problem that I saw with this approach was that crossing language boundaries is sometimes awkward. Now, it's never going to be as efficient to deal with crossing language boundaries as it is to work in the language itself. And also, a notebook written in another language isn't going to take advantage of the language features of a new language, especially one like Julia that's super concurrent and has pretty much a different spin on how some of the main things are done. So there's a notebook here that's called Pluto, and it is essentially rapidly gaining traction in the Julia community. So there's a little demo here. You can see that it's updating this row, and as he updates this row, then he can change the data here, and that will change the sum, even though this cell is above this one. And that's kind of a nice thing to have happen as you're working with a notebook, because it will allow you to track things that are related and play with them really efficiently. So for installing this environment, it's essentially just a Julia project. So you jump right into your package manager and then install it with an add, and that is it. And then it's just an import and run. So if I'm in Julia, all I need to do is enter the package manager with a right bracket, add Pluto. And then this is going to go quickly because I already have it installed. But then all I need to do is exit the package manager and then do an import and a run. So I'm going to say import, exit the package manager, then import Pluto. And then I can do, so that's pulling everything in. It has to precompile it. Now we're precompiled, so we're going to run this. And this is going to tell me to go to the browser. It's actually going to load the browser for me in localhost 1234, right? And it has a secret ID that that effectively allows just a little bit of security as it goes across the tabs here. But what we're going to do is create a new notebook, and all we're going to do is drop in the code from the model zoo. So this is the one that we're going to play with. And so I'm going to grab this whole program, except for the few lines on the bottom. We'll be able to call these directly from the model zoo. So I'm going to take this and I'm going to drop it in. Now, one of the things that you have to know is that Pluto requires everything in its own cell. But in this case, Pluto is going to have my back, and it's going to say, when I try to run this, it's going to say, hey, there's a problem. There's multiple expressions in one cell. What do you want to do? Well, I could wrap it up, but that wouldn't allow me to take it apart and play with each individual element. So what I'm going to do is I'm going to split it into multiple cells, and you can see that these cells are running piece by piece. So that's one way to do it. But what I'd rather do, localhost 1234. So what I'd rather do is create a new notebook and essentially drop things in piece by piece as I'm doing the experimentation. So let's go ahead and drop this much in. And so this is the main FizzBuzz function. So normally when you're doing machine learning, what you're going to do is grab some real world observation, and those real world observations are going to come from data that you've observed. And, maybe if it's a sales engine and you're building a content recommender, it's actually going to be actual purchases or actual interest. If you're trying to predict the price of homes, you probably pull actual home sales near you. We don't need to think about that when we're about working with the data for the most part. When we're learning the machine learning process, we'd prefer to work with a mathematical function that's well understood, like this FizzBuzz. Now, this one is interesting because it has a couple of obvious candidates for something called a feature. And a feature is a machine learning technique for categorizing data in a numerical way about one particular observation. Maybe it's the price of a house. Maybe it's the number of bathrooms if you're trying to price a house. In this case, our feature are whether something is divisible, well, actually the modular division for 3 and 5 and 15. So it makes a really nice problem for working with machine learning. So what I'm going to do is I'm going to just get a sense for how this works. I can see that this takes an integer, so I'm going to call fizz buzz 3, and I'm going to let that fly. And this is going to give me a fizz, so I could see that there's some string input. And so this is going to give me a, that didn't run. Oh, okay, I see. Yeah, and so I did a fizz2, and this gave me an else, right? And so the other thing that I can do is pass a range in here, and actually this is going to be a broadcast now. So since this is a range, this can translate to an array, and the period is going to broadcast or send it to each individual element. And now I can get a whole string of observations. So this is interesting. And this lets me know that I'm dealing with data that's really pretty much like real world data, right? It's not going to be something that's nice and tidy like an x squared function. And I like that. So this gives me enough meat as a machine learning problem to sink my teeth into, but it's not so much complexity at one time that it's going to overwhelm me. So I like that quite a lot. So let's go back to the model. And so now I'm going to, this is really, if you're thinking about where this fits in the overall learning part of the process, this would be the gather data. And so now, but rather than gathering data, we're just going to compute the data. And so this is going to happen with a function, right? And so what I'd like to do next is to work on the language features, right? And so this is called the feature engineering. And I mentioned that the features that we wanted to work with are these three. So modular division, which is effectively the remainder of a division operation for 3, 5, and 15. So let's go ahead and drop this much in there. So I'm going to press Shift Enter to run it and then split it. And so now I can see that I have my labels, and this is just a flat array. That's cool. So I'm going to actually strip that off so I can actually see the outputs, because I kind of like that. And then here's the feature engineering. You know, we could have that comment, but maybe a better place to put the comment is here in documentation. So I could say feature, but it's going to interpret this as Julia code. So what I need is a rapid way to say, no, I want this to be text. Well, the best way to do that is to say, hey, this is Markdown, and I'm going to give this a heading with 2 pound signs. And so now I have the feature engineering heading, and I can hide this to kind of keep this documentation intact as I go, right? So maybe we're going to here say something like, gather my data. Okay, perfect. And here's the feature engineering. And maybe this should be a next level head, just a little bit smaller. Okay. And so I'm going to actually play with these and see what they generate. So let's get, so this is expecting an X. So let's get the features for 1. Yeah, so this is 1, 1, 1. Okay, so what about, let's say 1.15, right? Just to get a sense for what all these features are going to do. And I did the broadcast here. Oh, look at this. It's already broken this down for me. It's already, so using multiple dispatch, I can accept an array version of this. And what this is going to do is horizontally concatenate all the features and call them, right? So all this is doing is flipping the orientation with an hcat. I'm going to take this and, there's my Elixir sneaking in there. Okay, and so you can see what's happening here. Every single column is an observation, right? This is 1, this is 2, and this is the features. So for 3, this is divisible by 3, but not 5 or not 15. If you go all the way to 15, it's divisible by 3, 5, and 15. So the job of this machine learning program is going to be to identify that what's important are the 0 values here, and those are going to map onto fizz and buzz and fizz buzz. And also that when there's a 0 in both places, it's going to prefer this one. So the weighting for this result should be higher than the other two. Okay, so we have a pretty good understanding of what the features look like. Now let's work our way on down. So we've done the features, and now we need to prepare the data. So we're going to say, so we're going to prepare the data. We'll hide this there, and we'll add another column, or really multiples here. So I want to get the data. And then after I get the data, I'll probably grab this line just so I can start to play with the data that we get. So let's go ahead and paste this much in there, and we'll let this fly. So that's a single function, so it's okay. So this is already wrapped. I can already treat this as one entity in the cell. So that's why Pluto's not yelling at me. This is a single entity. And there's a lot going on here, and I'm not sure I understand what all this is. Well, I mean, I've gone through this process before, so I know. But what I'd like to do at this point, if this is my first pass through, I want to start taking these individual elements apart. Like, I have a pretty good idea what this is going to do because we've already tried this, right? We tried this in this cell right here, right? And so this is going to be just a list of features, and this is going to actually, it's going to call FizzBuzz. So we've actually already done this too when we called FizzBuzz with a range here. So this is really the input to the model, and this is the output of the model, and the whole purpose of this program is going to be to make the two match, right? So what about this one? This is interesting, this test data. So this test data is going to say, hey, FizzBuzz for 3 should be the first label, for 5 should be the second, for 15 should be the third, and 98 should be the fourth, right? For FizzBuzz, and else. And so let's actually just run this much. This is like an assertion in Julia, right? So if this is wrong, right? So what if I said 99, which is divisible by 3? That's a fizz. And so I'll run this one again. Okay, so, oh, yeah, this is a problem, right? So, so we want that to be a 98. We want to try that as a 99, right? All right. Okay, yeah, so it failed. And so this is actually going to throw an exception if there's a problem here. This is actually part of the Julia testing, the testing framework, the testing strategy. So let's go ahead and let that fly. It's kind of cool that we have a test case actually embedded in the code itself. That's a great way to write code, I think. It's interesting. All right, so let's go ahead actually try some of this out, right? So what is this one hot batch? So let's go ahead and see. So I can take this apart actually like this just to see what the individual pieces are and run that much. I wonder if Julia would have split that for me. I don't know. Okay, we're going to carve this up, and we're going to let them, so they're actually running as we speak. So what we want to do is see what this thing actually returns, right? Oh, so the semicolon is going to suppress the output, and that's not what we want, right? We want to see what's happening here. And then, yeah, and here we probably don't need to see that output. So this is the FizzBuzz with the exception of rather than using the X element here, we're actually, so when X is 1, we print else instead. So this is really FizzBuzz else game, right? And let's see. So we need to remember that inputs are a 3-row data set for each of the features, and the output is a 4-row data set. Okay, and this is what a one hot batch is going to do for me. You can see that we've actually carved this up and encoded it as if we were kind of tracking through survey results, right? So having a 1 in the last column, this would be fizz, buzz, else, and FizzBuzz. So it's else for 1, 2, fizz. So that's a 1 in the first column, which is fizz. Else for 4, and buzz, that's 5. And then fizz again, because that's divisible by 3. 7, 8. Fizz for 9, buzz for 10, on and on and on. And then we're going to get a fizz, cut us off right before the FizzBuzz How sad. So these are essentially, it's essentially building a tabular structure where every single row has its own category, which is a great way to represent data for the class of problem that we're solving, which is a machine learning categorizer, right? Okay, so now we can move on down the list, and we're just going to go through the whole program this way. We need to make a decision whether we're going to import this whole monster function at one shot, or if we want to kind of take it apart. Now, this is the function that does the bulk of the work, and it might be interesting to see the impact of one training step, but since the model and the test data are all embedded here, that's not going to help me very much. So what I'm going to do instead is start to work through this in chunks, and then I can delete all that or just build another version that's actually wrapped into train later should I choose to do so. But I think for right now, what I'd like to do is, so we know what get data looks like, but we're going to need the data for our system. So let's do that. And then I want to look at the loss function and the model next. So let's go ahead and grab the data in the model, and we'll come back when it's time to do the loss function. So let's do that. So I'm going to drop this in here, and I'm going to run that. It'll ask me to split. I'll do so. Great. So now I should have my data, multiple definitions for X and Y. I already have these pieces. I don't need this this column, right? Because that's what I was returning anyway. This is my input data. This is my output data anyway. So that's doing exactly what I want. And so let's look at the model. Well, the model is just chained together a couple of dense layers, and I'm not going to talk about exactly what the dense layers is beyond saying that they're just functions. So we could play with a layer, or actually we could say m.layers and let that fly. And you can see that there are two layers in here, dense 1 and dense 2, and we could extract those like this. So L1 and L2, and these are optional in that case, right? So that's all I'm doing. I'm just extracting the first and second layers. So I'll let that fly. And now I could see L1, right? And let's see what dense is. So if I say dense, I could say field names of dense and see what's in there. So this has a W, a B, and a sigmoid. And the sigmoid, this is an activation function. And so we could actually see what each one of these are, right? So I could say, give me L1 dot W, L2 or L1 dot B, and L1 dot, and then the sigmoid. So I could type it in the Julia console, right? There's a helper function to do that. But let's go ahead and let this fly. You can see that what's happening here is that these are configurable weights that are initialized to random numbers, right? And this is essentially the initial bias, and that's going to be configurable as well. And this is the identity function, right? So that's all the layer of a neural network is. It's a functional pattern with configurable parameters and an activation function. Normally, we'll have a complex activation function or a nonlinear activation function if we want to make nonlinear predictions. For reasons that I won't get into in this video, we won't do that in this case. But what I'd like to show you is that we can actually run this model to make predictions now, right? So I could say model, and it's going to take an X. But what's the X? Well, it's going to be the features for a number, right? So I'm going to say, give me the features of 3, and let's see what's predicted. And so the way to read this is that the highest number in this list, and that's this one right here. So this is predicting fizz buzz, or it's actually predicting fizz buzz. It's predicting buzz for a 3. Well, it's not correct, but it's not going to be correct most of the time because we haven't trained it yet, right? So what we're going to do is train these parameters over and over and make them better, right? Well, how do I tell how good or bad something is? Well, I look at the loss function, and the loss function is next, right? And so this loss function combines logistic and cross entropy, right? So this is an activation function, and this is a loss function. They're just combined for efficiency and accuracy. So I'm going to go ahead and drop in this loss function, and we're going to try it. Okay, and now we're going to get a new line here, and we're going to try loss. And then I'm going to call the models with an X, right? So which is M of features of, or actually I could just pass it. I already have the features for the X data set, right? And then I could pass it the whole Y, right? And what this is going to tell me is how good of a prediction that this is. A higher number is a worse prediction. Let's see, M of X. Oh, no, it already, yeah. So my problem is that the loss function already applies M for me, right? So this loss function already applies X to my model. So I need to pass in the actual training data inputs and the training data outputs. And that will tell me what my actual loss is. So the loss in this case is around 5. And the whole process of machine learning is reducing that loss. So if we go and actually build a helper function to make a prediction, I guess we could drop that in there. No, let's actually build a model real quick. And I'll actually just drop that model in there. And so this is just a tool that works with the train function to make things better by one step using a tool called automatic differentiation. It takes the gradient of the whole loss function, and that's how rapidly things are changing. And the loss function is going to be steeper in up direction if the loss is getting worse. So it'll chase the gradient in the opposite direction. So it'll actually subtract. Make subtractions all the way through all the parameters and then tweak the parameters and make them better. And so we could see this in action. Let's actually see that training step in the model zoo. So here's a training step, right? And this is just the loss and the parameters of the model, and that's just those W's and B's. This is just the training data, right? So this is the X and the Y in a shape that the train function likes, and there's the optimizer. So we could take that and we could run this. So here's the loss. Let's see if we can make that go down. Right, so now we have to do a little bit of compilation steps. So this is going to take a little bit. But when it finishes, we ought to be able to run this loss again and see what happens. So let's let this happen. Okay, now it looks like we have some output, or it looks like it's done. So now, oh, look, the loss went down. And now this will be quick because it's already compiled, so we can run that step again. And yeah, it just took a few milliseconds, and now we can run the loss again, and that went down. So it looks like we're going to have to run this many times, which is exactly what you're seeing right here, right? And so there's this monitor function, which kind of shows what's happening along the way. This deep buzz is actually going to be using the model to make a prediction. So let's actually see what happens here. So we're going to get Get a new cell. Call that deep buzz. And now we ought to be able to say, so the reason that we do that, this is actually going to call the model. So this is going to pass out one of those hot encoded grids. And we actually want to extract the actual argument. So let's say deep buzz. Let's call it with like a 5, which it should get a buzz. It did. How about that? How about with a 3? Okay, that's also getting a buzz. How about like an 8? Yeah. So these. So this is not getting a very good mix at all. In fact, I could say for 1 through 15, what does that look like? Oh, I need to broadcast that. So yeah, I get buzz, buzz, buzz all the way across. So how do we make that better? Well, what we're going to do is call the training step a number of times in a row. So let's do that. I'm just going to call it 500 times, and we could call it more if we want to. Oh, I need an end on there, so we'll let that fly. This is running really quickly now, and so I bet that my loss is much lower now. Yeah, look, this loss is way down, and I bet these predictions will get better. Yeah, 1, 2, fizz, 4, 5, up. It missed this one, so it's not perfect yet. So fizz, so it's got the fizzes. Let's run 500 more training loops. And so we just did, and let's see what the loss is now. So the loss now is 0.18, and now we can see what's happening with the deep buzz. Yeah, so 1, 2, fizz, 4, buzz, fizz. So this is exactly correct. So it looks like we've converged far enough for an accurate model. So anyway, we didn't get into all the details, but I hope this gives you a sense for the way that we can use the Pluto Notebook to actually explore what's happening in the more complex machine learning segments. And that's an excellent thing. If you want to know more, join us at Groxio Learning as we explore Flux. From Bruce and the dog on the floor, this is Groxio Learning.